Hello, precalculus class. Today we're going to learn about using Cramers Rule to solve a system of equations using the determinant of a matrix. Go ahead and try this warm-up, and then we will go over the answers. Pause the video now. And your answers. So remember, you do the down diagonal product minus the up diagonal, so that's minus -2. You end up with a 23. And this one you end up with a 0 minus -16, so you end up with a 16. So this is what Cramers Rule is all about. So if we have two equations containing two variables, you can see our system of equations here. And what we're going to do is we are going to use the determinants, and we'll start with the determinant of the coefficient matrix. So if you look here, A, C, B, D are the coefficients of the x and the y term. And if we find that determinant, we're going to call that D. That becomes the denominator in both of these answers. And then if you take and want to solve for x, you have to find the numerator's determinant, which is actually the same thing as the bottom, but we replace the coefficients of the x with the solution values. And then for the y, we do the same thing. We take the determinant from the bottom, or the matrix from the bottom, and we replace the y coefficients, b and d, with the solution s and t. So there's a nice little summary of this, and we call this upper one here the D sub x matrix and the D sub y matrix, or determinant of those matrices. And so I will page it down so you can see more about it here. And that will give you your solution x and y in that original system of equations by doing those divisions. The key, though, notice, is the determinant, the denominator's determinant, your coefficient determinant, cannot be 0. We will do an example on the next slide. All right, let's go through this together. So the first thing I need to do is I'm going to solve for x, which is going to be d sub x over d, and y is going to be d sub y over d. So I need to go find those three determinant values. So D is going to be the determinant of the coefficients of my system. So remember, in the augmented matrix, when we had set it up to do row operations, you'd write it like this. And we're finding the determinant of the coefficient part. So let's go ahead and do that. 12 minus -30. We end up with a 42. We're going to hold on to that value. So now we need to set up and find the determinant sub x. So this is the same determinant we had before, the coefficient matrix, but the x coefficients, this column here, will be replaced with the solution column. So I'm going to write 24, 12 here, and then I rewrite the -6 and the 4. And we got to find that determinant. And we'll do the same thing for y. Instead of replacing the x column, we're going to replace the y column. So we rewrite the coefficients of the x, and we put the solutions in here for the y. Now we can go through these calculations. So for the x, you're going to have 96, and then it's minus -72. And over here, you're going to have 36 minus 120, and we end up with a determinant value of 168, and down here we have a determinant value of -84. So we can finish the work. We'll go back up here. X equals d sub x, which we found to be 168, divided by 42, and that kind of works out nicely. It divides in an even 4 times, so x is 4, and y is negative 84 divided by 42. And that also happens to be a nice easy problem, and you end up with a negative 2. So the solution to the system is 4, negative 2. And that's Cramer's rule. Now, would I use Cramer's rule on a 2 by 2? Probably not. So I am showing you lots of different ways to use matrices to solve a system of equations. And the key is matrices are going to be the way to solve the very large system of equations, especially when we use it with computing technology and the graphing calculator. And I'm just kind of showing you the math underneath this process. So we are going to use Cramer's rule to solve a simple 2 by 2, even though it may not be the best tool in the toolbox for this problem. Just like a 2 by 2 can be solved using Cramer's rule, likewise, we can solve a 3 by 3 system using Cramer's rule. And what's really nice is the summary is exactly the same. So here is a 3 by 3 system of equations, 3 unknown variables, x, y, and z, and we have 3 equations with 3 solutions. Each equation has, its c value, if you will. But the solution is going to be the x variable is going to be the d sub x determinant divided by the d determinant, which, if you recall, the d determinant is the coefficient matrix determinant. And it must not equal 0. We'll talk more about that later. And y is found and z is found the same way. The d sub x matrix, you replace the x column coefficients with your solution column. Y, same thing, and z, same thing. So we're going to do an example here with this system. The first thing I'm going to do is find d, and let's set that up. That is the coefficient matrix. So we have 1, 2, 1, 3, 5, 1, 2, 6, 7. Why don't you pause it and find that determinant, and then unpause it, and I will give you the answer. The answer to that determinant is negative 1. Okay, so now we need to find d sub x. And let's just set up d sub x first. D sub x, we're going to replace the x column coefficient with the solution column, 1, 3, 1, and the rest stay the same. And when you go ahead and find this determinant, pause the video here, you will have a value of 2. Let's go ahead and set up both d sub y and d sub z. So d sub y is the same x column as before, but replace the y row with 1, 3, 1. Keep the 0. Likewise, let's fix that. That's just a 7. Likewise here, the x row doesn't change. The y row doesn't change. But when you get to the 0, you replace it with the 1, 3, 1 value. Now go ahead and pause it, find both those determinants. The d sub y determinant is a negative 2, and the d sub z determinant is a 1. So we can finish this problem using Cramer's rule. The x will equal the d sub x over d, which in this case is 2 over negative 1, and it's negative 2. Y is going to be d sub y, which is negative 2, over d, which is negative 1, and we get a 2. And z is going to be d sub z, which is a 1, over d, which is a negative 1, and we get a negative 1. And the ordered triple response to that system of equations was negative 2, 2, negative 1. And that is the result using Cramer's rule. All right, so these are the notes you need when you're dealing with an inconsistent or a dependent system. If you recall, whenever I said, hey, if that coefficient determinant ends up equaling 0, you're going to have a problem. So if you end up with the denominator being 0 you know you have a problem because you can't divide by 0. But if at least one of the determinants d sub x, d sub y, or d sub z is not equal to 0, so let's say this is 3, that's when you have an inconsistent system. So there's no solution. So at least one of these. So d sub y could be 0 over 0 here, but as long as 1 isn't equal to 0, it's inconsistent. Okay. The second situation is when it's consistent but dependent, which means there's an infinite number of solutions. This means all determinants are 0. So you end up with d sub x over d. Both of these are zeros. Likewise, d sub y over d. Both are zeros. And d sub z over d. Both are zeros. Or, if it's 2 by 2, and they're all zeros, then it's consistent and dependent, and we have infinite solutions. So be on the lookout for those two situations. I'm always kind of ready to see it as soon as I get d is 0. And if it's consistent and dependent to actually solve the system, we can't use Cramers rule. So it says then the system must be solved using row operations or row reduction techniques, or you can just go to regular system of equations processes. All right, to wrap it up, we're going to do this word problem here. So the first thing you want to do is read through the problem, assign your variables, and set up a system of equations. Go ahead and pause it here to ponder that, and then I will show you that part of it. All right, so this was a little confusing to set up the system and assign the variables. I always go to the question mark. How many cars of each type can the company produce in a month? So that's how I assign my variables. We have 3 kinds of cars. We have delta, beta, and sigma cars. So when I assign my variables, therefore, the number of deltas, the number of betas, and the number of sigma cars. So I use D, B, and S. Now, there's tons of numbers in here, but the key is it says the company can spend a total of 240 hours painting, and they can split it between the different cars. 69 hours drying and 41 hours polishing. So depending on how long it takes a beta to polish, they can only do so many beta cars. If they only did beta cars, they may not use all their hours for painting or something like that. So it's what combination uses all their hours and gets them kind of the number of cars they can produce. So I have an equation down here for painting hours, drying hours, and polishing hours. And notice these 3 numbers, 240, 69, and 41. That's the total of painting hours, the total of drying hours, and the total of polishing hours. So this is where I go through each of these sentences. Each delta requires 10 hours of painting. So for every delta, it's going to take 10 hours of painting. 5 deltas, 50 hours painting. And then 3 hours for drying for a delta, and 2 hours for polishing. So they go into each of the totals for painting, drying, and polishing. Likewise, your beta, we got 16 hours painting, 5 hours drying, 3 hours polishing. And your sigma, 8 hours painting, 2 hours drying, and 1 hour polishing. Now that we have the system of equations, we can solve this using regular system of equation methods like elimination or row operations that we learned before. But we are going to use Cramers rule, and I'm also going to show you how to do it with the calculator. So remember last lesson you learned how to use the second matrix operations buttons. Well, there's a choice in the menu math for determinant, and anytime you have a determinant that's bigger than a 2 by 2, I recommend once you've learned how to do it, now you can use your calculator. So let's first set up our Cramers rule situation. And that means we have to identify what our capital D or your denominator is going to be, which is your determinant of the coefficient matrix, which is this right here. Then we need D sub x, which is taking your X column. Actually, I shouldn't call it X, should I? It's D sub D because this is about your deltas to solve for D. And this determinant replaces the first column with your solutions. This is why we do not want to find these determinants by hand. They're very large calculations. And then we have D sub B. And we replace the B column with our solution column. Lastly, we have D sub S, which is the S column being replaced with the solution column. All right, so now we go through and use diagonal method to solve all of these, but instead we're going to use the calculator. What you're going to do is choose second matrix, and then you are going to choose edit. You're going to enter now. When you enter it, we're going to enter, you could just keep doing it all in naming it A, but it has to be a 3 by 3. So make sure you change your dimensions to a 3 by 3. You go ahead and you enter your matrix values. Then you want to get out of that and you want to go back into second matrix, choose math. You'll see the first choice is determinant. You choose determinant. Then you go back into your second matrix menu and choose the one that you just saved. So that first one, I put it in A, hit enter, and it will give you the determinant for it. And using these calculators, the coefficient matrix D, you end up with a -2. D sub D, you have a -16. D sub B for your beta is a -10. D sub S, your sigma, is a -20. So, to solve the problem, we'll start with D, your delta cars is going to be your D sub D -16 divided by -2, and we end up with 8 delta cars each month. Likewise, your beta cars is going to be your D sub B, which is -10, divided by D, which is -2, and you have 5 beta cars. And finally, your sigma cars is -20 over -2, so 10 sigma cars. And that's how many they can produce each month given their requirements on their factory line for painting, drying, and polishing. That's it for the lesson. Go ahead and try your homework.